web applications, with the web application overview, we will discuss the protocol that is used by web applications to exchange data. All right, this is the hypertext transfer protocol. Now, HTTP relies on TCP connections in order to transport data at layer 4. Okay, there are some cases where HTTP is encapsulated in UDP connections, but normally TCP is what is used. Now, HTTP is a stateless protocol. Okay, it means that there are no handshakes for HTTP. HTTP work is a request-response protocol. It means that if I am the web browser, I will ask the web server, hey, I want this resource. The web server say, hey, this is your resource. Goodbye. That's it. There is no history. There is no memory. There is no tracking down who I am and who requested what. Okay? So this is how HTTP works. Of course, since we are using TCP at layer 4, we can use the reliability of TCP if something bad happens. Okay? If some packets have to be retransmitted because they are never arrived or they are damaged and so on, TCP will take care of that. Now, when HTTP was developed, it was developed without any security concepts. Zero. Okay, not just a little bit, zero security concepts. And in order to understand this, you have to basically imagine how, basically when HTTP was created, where the web server was and where the client was. It was in the same system, right? At CERN, they created the web server, and then they created the web browser. Then the web server, since more people were using it, was moved, maybe from the desk to the floor. So now you have a computer, which was the client, which was interacting with this web server, which was on the floor, right next to my desk. Then more people wanted to interact with this web server, so we had to buy a bigger server with more capacity and so on. So the server was moved from the floor next to my desk to the other room, because now you need more space. You need an environment that was able to handle this server. Then it was moved again from the other room to downstairs, where the data center is. Okay, so we have lost. I mean, we could see maybe the web server in the other room, but now we cannot see it anymore. It's in the data center downstairs. And then it was moved from the data center downstairs to somewhere, okay, maybe in co-location with other servers. And then it was moved again from somewhere to the cloud. Okay. Nowadays, you connect to a website, you don't even know where the web server is. Okay. Not even web developers sometimes know where the web application will be hosted. For example, if you put them in the cloud. So we are using a protocol that first, it was never intended to be used the way that is used today with web applications. So we are abusing HTTP, and we're using a protocol which is not secure. And this is the protocol that we use to transfer data, to transfer bank, for example, statements through web applications, to make bank wire transfer. This is the same protocol that will allow you to exchange data with LinkedIn, to communicate with your colleagues, for example. Okay? Exactly the same protocol. And we will see what we can do to increase a little bit this, the security of HTTP. All right. I was just checking the batteries of my mic. Now, as we said before, there are no handshakes on HTTP. So a typical HTTP session is made of an HTTP request which contains a request message, and an HTTP response, which contains a response message. The request is normally done by the browser, and the response is done by the web server. Okay, so it is completely stateless because, again, this is an HTTP session. Okay, and as you can see, there are no sequence numbers. There are no tracking mechanisms behind this, which is very bad for what, if you think how we use web applications today. Now, in order to locate the content of our web application, a web browser has to use an address in the request message. Okay, now this address is called URL. Okay, now URL are used to locate HTTP resources, okay, to get something from a web server. Normally, URLs are included in a bigger group that is called URI. At the beginning, when HTTP was created, there were two identifiers. There were the uniform resource locators and the uniform resource names, okay, URNs. So URLs plus URNs made the URIs, the uniform resource identifiers. Now, nowadays, URLs are the ones that are used most. Okay, we don't use URNs to access our resources on the internet. We use URLs. Now, in the WEF, when in the configuration of the WEF, sometimes you will see URI. Okay, because sometimes you really have to be strict. Okay, you really have to be specific. All right. So if you see URI, you can put a URL inside there or URN. Some other times you will see URL, okay, in the WAF configuration. Just know that for the WAF, for our course, URI and URLs are interchangeable, okay, even if strictly speaking they are two different things. Now, a typical URL is made of a scheme name. This identifies how to access that resource. All right. For example, this scheme name is HTTP, but this could be FTP, for example. Right. So if you have FTP, we are going to use the file transfer protocol. Now, if you use HTTP, you're going to use the hypertext transfer protocol to access that resource. Then we have hierarchical part, which is made of a host and a domain. The host here is BadStore, and the domain is qdu.org. All right. Then we have a slash, and you might have a question mark with something equals something. Then you might have an ampersand or a semicolon, and then you're gonna have again something equals something, and then you can have a hash with another word. Now, all these things that you see after the question mark are called URL parameters. So in the WAF configuration, if the WAF will ask you, how many parameters shall I accept for the request to this web application? And you put 3, these are the numbers of parameters, 1, 2, and 3. Okay? So as you can see, we're now starting to see the relationship between the basics and the web application firewall. Now, everything that is after the question mark, but before a hash, is called a query. Okay? Depending on the method that you use in your request, a query can be included in the URL, like we're seeing right now, or in the request message body that we will see in the next slide. Okay. Now, everything that you see after the hash is called a fragment. Now, what the hell is a fragment? A fragment will allow you to identify a specific part in a page of a web application. Let's say that, for example, you want to see the history of, I don't know, Germany. Okay, so you go to Wikipedia, and then you got the whole article for Germany with economy, with culture, with history. Now, if you want, if the developers have allowed it to do this, you can go directly to the history section by appending #history. Okay, for example. So if you bookmark this URL with the #history at the end, then and you open that URL, the browser will automatically, of course, load the whole page and then scroll down to that specific part of that page. Okay, this is basically a fragment. Okay, identifying specific parts in a page. Now, URLs are used to identify resources. Then, in order to request a resource, we have to create a request message that is then used in the HTTP request. Now, a request message is made of 4 parts. We have the request line, the request header field, an empty line, which is mandatory, and the request body, which is optional. Okay? So if the query, as I said before, was using another method, okay? Methods are get, put, post, we'll see in a moment, then that query would have been put in this part of the request message, okay, in the body. All right? Now, let's analyze the components of the request message. Now, in the request line, the first item that we have is the method. How are we going to interact with this remote resource? Then we have the URL. In this case, we can put, for example, slash, so we can put a relative URL, /cgibin /bedstore.cgi. Then we have the HTTP version. Okay, the most common version of HTTP nowadays is 1.1. Okay, so this is the web browser that is doing the request for you. Okay, you don't have to do this. It's done automatically by the browser for you. Then we have an additional part of the request line that it's called the host or the server domain name. Okay, now this is basically what kind of what web application we want to query. Okay, we want to retrieve. Because with the introduction of HTTP 1.1, it was possible to host multiple websites, multiple web applications on the same web server, hybrid server, application servers. So what is happening is that you might have that in the same server, you have bbc.co.uk, bbc.com, bbc.us, for example, bbc.co.nz, okay? And by using the host field, you can then pinpoint the right version of the web application. Okay, you can have, for example, a WordPress website, for example, a Drupal website in the same web server, and then just call the different web application depending on the host header. After the request line, we have the request header field. Now, the request header field will contain some additional information that might be needed to communicate to the server when we are requesting data. For example, we can have a user agent. Okay, user agent is basically the entity that is requesting the resource. Normally, a user agent is a web browser, but it's not always the case. The scripts, the automated scripts that Google use to crawl all the websites, these are called user agents as well, okay, even though they are scripts and they are not web browsers. The user agent part, accept language, accept encoding, these are called header names, okay? Then we have a header value. A header value is the definition of what you have after the column, okay? For example, Mozilla, text XML, HTML, gzip, deflate, and so on. If in the header value you have multiple values that have to be specified, like for example in the cookie header, these values are separated using a semicolon. Right? So here you have two cookies. One cookie is called ID, the other cookie is called token. These two cookies are separated using the semicolon. Okay? Again, this is very, very important. Okay? Because again, the WAF will tell you, all right, what is the maximum header name in the request? Now, this is the header name, and the WAF is asking you how big this field can be. All right? And then you can put a limit here, for example. Let's say you can put 4K and or 32K or whatever. For the request methods, we have different types of request methods. Okay, when we are requesting the resource. Remember, request methods is the first thing that you see in the request line. Okay, this is the method get. Okay, we have get, head, post, put, options, delete, connect, and so on. Let's just cover a couple of them. Get will basically retrieve data. I want to have this page. Thank you very much. Okay. Post will do the same as get. The difference between get and post is that post uses the request body. Okay. So in the request message body, post is going to put some information, right, like the query. Head will basically just get the headers from a web server without the body. Okay, we just say, yeah, I want to see, for example, what's the connection, the compression, and so on. Put will put files into web servers. Okay, so this is, for example, when you use web servers, when you have a file server that has to be accessed using HTTP. Okay, put will actually put the file when you are, for example, attaching a file into a web application. This might use the put method. Options will basically retrieve all the methods that are supported by the web server. Not all methods are supported normally. Okay, the web developers might say, I only want to use get and post. Full stop. That's it. Then we have other methods. Delete will delete a content. Trace will basically mirror your request to see if there are other entities in between. And then one of the most interesting methods that we can have is connect. Connect normally is used if you have an HTTP proxy. So if your company, for example, is filtering internet traffic and you have to access a remote resource, your web browser will not request the resource directly. It will actually open a connect request to the web proxy, and then the web proxy would then use get, head, post, put, whatever, to get the resource. Connect is also used by SSL or TLS sessions. If you have to establish an encrypted channel before you transfer data, then connect is what you use. Okay. Then we have the HTTP response. This is the response from the web server, and this is how it looks like. This is the supported protocol that we have, HTTP 1.1, for example. And then we have a status code that will basically tell the browser what happened. Okay, all web browsers must be able to interpret status codes. We are humans, so we might forget. So we then have some information on output as well. Okay, like OK. This is for status code 200. Then we have some response headers as well. Okay, we have, for example, the server technology. This is Apache 1328. When this resource was last modified on the server, what are the content type that we are transferring, and so on. Okay. Then again, we have an empty line, and then the response body, which is the actual content. Okay, the content of the page. Now we have different types of responses. We can have 100 responses, so 101, 100, which means continue. We discussed this about for example, 101 when we talk about web sockets. Anything that is in the 200 is success. Anything that is in the 300, like 301, means permanent redirect. So if the browser will actually get a response with 301, it will then search for another header that is called location, that it must be included by the web server, and then the browser will go into that location, and then the same for 302, which is temporary. Remember, 301, prime, permanent. Okay, 302 is temporary. Then we have, for example, 304, which means you have the content, look into your cache, web browser, don't ask for this content because what you have is valid. We have 400 errors, for example, 401. 404 is not found, the most common errors that you see around. 403 means forbidden. You're not authorized to access specific content. 401 means authentication required. Okay, so this, for example, will trigger the authentication process. 500 errors are server errors. Okay, if something bad happens to the server, you will have, for example, 502 gateway unreachable or something like that. Okay, so these are errors that are generated by web applications or web server technologies. These are errors that are generated by the client itself. Okay, so for example, you type in a URL of a page that does not exist, you get a 404. Okay, now let's actually see an example of this of an HTTP request and an HTTP response. I'm going to use a tool that is called ZAP that we're going to use in the lab as well, and we will discuss about ZAP later in this course. This tool has a manual request editor. Okay, so we can actually forge a request. Okay, actually, let's close this. Let's clear up the cache, and let's open ZAP again. Now, ZAP is written in Java. So during the lab, if you double-click on the icon and you see that it's taking a lot of time to load, don't click again on the icon, otherwise you will get errors. Okay. Now, let's manually generate a request. Okay, and see the response. Now, the first thing that we need is a method. Let's say that our request is a GET request. Then we have to identify the URL. In our case, we can put slash. Slash means give me the default page that normally you should provide to the request, to a request which is asking just a slash. Okay. Then HTTP is going to be HTTP 1.1, and then we have the host. The host in our case is, oh sorry, you can't see our screen, my screen. Sorry, let's do it this way. All right, can you see it now? Yes, fantastic. So this is ZAP. This is basically the manual request editor that I'm using. The method is GET. I'm going to request the default page, which is configured in the web server, using HTTP 1.1. And the host is going to be badstore store00.qw.org. Okay. Then we have some headers here that are pre-populated. User agent. Okay. This is basically my browser. In this case, I'm not using a browser. I'm just forging this request. Some content type, and then we don't want to cache anything. Okay. We don't support caching. Now, let's create this HTTP request. I click send, and this is the response from the web server. We got HTTP 1.1, so the web server is able to understand HTTP 1.1. We got 200. OK, that's fine. We have the server definition and so on, whatever we have seen in the previous slide. And this is the body of the response. This is the actual page. This is if you right-click and click a source code on a web page, this is what you see. All right. It is the same as going to open in your browser and go to badstore 00.curiou.org. That's the same thing. Okay? That was forged by using Zap. In my web browser, I just have to type in the URL, and my web browser, behind the scenes, I've done all this. Okay, creating headers, specifying HTTP protocol, the method, and so on. Everything was done automatically by the web browser. So you don't have to remember anything. It's just done pre-programmed in the browser. There is a question, is the hands-on lab part of this class too? Yes, in this class, we are going to have 5 hands-on labs. Okay, one is going to be today. Then we have a couple tomorrow, or 3 tomorrow, and another one on day 3. It depends on the timing. Okay, we will see how far we go with the course, and then we will decide when to do the labs. Okay, so this was a typical HTTP conversation: a request, a response. Problem: what happened if I am logged into Amazon and I want to buy something, and Amazon, the Amazon web application, cannot remember me? Because, again, an HTTP session is request, response. If Amazon doesn't remember me, how can I be logged in and at the same time putting something in the cart, and at the same time the system should remember that I put something in the cart while I'm logged in, and so on? Using HTTP, plain HTTP, this is not possible. That's why HTTP is using a small piece of data that is sent to the browser, which is called cookie. Okay, cookies are the root of evil. No, they're not the root of evil. Cookies are used by HTTP to track down sessions. All right? Since there is no relationship between sessions, we need to have a way to say, Tommy's logged in. Yes. Tommy has put 3 items in the cart. Okay. Tommy's now paying for these 3 items. Okay. So cookies are, you have to see cookies like sometimes there are meaningless information from a user point of view. Other times you can look inside the content of cookie to get some information. But normally these are generated by the web server, okay, or the web application. So after the first request or any other request, a cookie is injected into the response header, and the cookie is then saved in the browser. Okay. Now, all browsers are programmed to use these cookies for any other requests. So as you can see here on my second request, the browser is using this cookie. Okay. All browsers will behave like this. Okay. Now, you might be thinking, well, this is how they track me. When I'm browsing Amazon and then I'm on Facebook and they are showing me those adverts for those sneakers. Yes, this is also how they track you between websites. Okay, so unfortunately, as I said before, HTTP has no security features in it. All right, so we have to really, really be careful when we are using our browser, and we also have to be careful when we are protecting our web applications. Now, there are different types of cookies that can be generated by a web server. We have session cookies that are used to track down sessions. Am I logged in? Yes, no, and so on. Who are you? Are you Tommy, Jack, Jim, and so on? Okay, so these session cookies are used to track you down from a particular session. Then we have persistent cookies. Persistent cookies normally are not linked to a specific session. For example, let's say that you set the time zone of the campus portal to Berlin, the Berlin time zone. All right. Now, you're not logged in. You're just setting the time zone so you can see the available courses for this time zone. Now, this is stored in the cookie. and then the cookie is sent to the browser. So the browser, every time that is requesting content to the web browser, is actually saying, hey, I'm in the Berlin time zone. I want to see these courses. Okay. Somebody is reporting that I have audio-video issues. Can you see me and hear me correctly? It's glitchy. It's better. All right. Yeah, maybe some internet connectivity issues. It can happen. All right. So thanks for the feedback. So persistent cookies are not linked to a specific session, and they will basically stay in the browser and used whenever it's necessary. Then we have third-party cookies. Third-party cookies are some cookies that do not belong, for example, to Amazon.com. Okay, they belong to another domain, but they are generated anyway during that request and response session because the web application decided that in order to get the content for that specific page, the web browser needed to access multiple resources, multiple locations. So those cookies are generated and then saved into the browser. Then we have super cookies, which are very bad. Normally, browsers should block super cookies by default. These are cookies that are valid for a top-level domain in the origin. So you can have a super cookie that is valid for .com or .de, .at. This means that that cookie is valid for all websites that finish with .com, Microsoft.com, Apple.com, Barracuda.com. It doesn't matter. That cookie will always be used, which is really, really bad, okay, from a security perspective. That's why normally these cookies are not, let's say, they are filtered by web browsers normally. Then we have zombie cookies. Zombie cookies are very nasty piece of data that automatically recreate themselves even if you clear the cookies in your browser. You might be thinking, how? Now, there are several parts in the browser where cookies can be saved. Don't think that because you have cleared the cookies and the cache of your browser, now your cookies are not there anymore. That's a lie. That's not true. Okay? There are several pieces, several storage containers that the browser can use to save your cookies. For example, if you use Flash use a specific part of your file system to store cookies, which is not the same part that the browser uses to store other cookies. The same is with Java. Java stores cookie in another part of your file system. All right. So you cannot really get rid of these cookies unless you clear up your profile altogether. The only way that I know of to prevent this zombie cookies from infesting your system is by not accepting them. Okay, which will allow you to know what you are doing. Will allow you. You have to use some kind of add-ons in your web browsers and so on. Okay, again, it's not easy to get rid of zombie cookies. Now, if we take a look at the cookie attributes, normally when the web server is creating the cookie, you will see in the response header this set cookie header. Okay, this is the web server saying, I am creating this cookie. All right. Now, the name of this cookie is SSID. And the value of this cookie is DDH9D9. Then we have another value. You see, we have the separator. After the name and the value, we have the domain where this cookie is valid, .qdo.org, and also the path, in this case, everything. Okay. What your web browser will do is will basically check the domain and the path in order to see if it is necessary to use that cookie or not. Okay, so if we have a cookie that is valid for Microsoft.com, that cookie is not used in the qdo.org web application. okay, or domain. All right. So the validity is actually specified in the domain and path values. Then we have the expiration date, when this cookie is going to expire, and two flags, secure and HTTP only. Okay. Now, the secure flag means that the cookie can only be used if there is an HTTPS session in place. It means that if you're not using an encrypted channel to transfer data, that cookie will not be sent by the web browser to the web server. All right? So HTTPS in place, all right, cookie used. HTTPS is not in place, cookie will not be used. The HTTP only flag will basically tell the web browser to disallow any client-side script to use and access that cookie. So this specific cookie, this SSID cookie, as it is written right now like this, will only be used with HTTP sessions, okay, to transmit the cookie back and forth. If in the web application technology, in the web application code, we have a client-side script that says, get the value of SSID, that script cannot access this cookie because this flag is in place, and the web browser normally will prevent this. There is a question, so it can be either secure or HTTP only. No, it can be both. Okay, these two things will do two different things. Secure, make sure that HTTPS is in place. HTTP only, make sure that no client-side scripts can access the cookie. So this is regarding to transport. This is regarding to how the cookie is accessed. Is that clear? I mean, both flags can be on at the same time. Yes, both flags can be on at the same time. Okay, so you can have secure and HTTP only, or you can have a cookie that is only HTTP only or only secure. It depends. Okay, this is normally set by the web application. With the WEF, we can override this. Okay, with the WEF, we can say all cookies must have the secure flag and the HTTP only flag set. Full stop. Exactly. So a cookie that will only have the secure flag in it will only be used for HTTPS sessions. Okay. A cookie that will only have the HTTP only flag set can be used for HTTP sessions, for HTTPS session, but client-side scripts cannot access this cookie. So that's the difference. So there are different ways that we can actually track down HTTP sessions. Now, cookies are just a way. All right, we have the session cookie. But we can also use headers, HTTP headers, all right? So we can have the basic authentication header that is sent back and forth between the web browser and the web server to say, hey, I am authenticated, all right? We can use the IP address, okay, the source IP address in the IP packet. We can use client-side certificates, okay? If the client has a certificate, then that client can be identified using that certificate. Or we can use the Windows domain credentials. Okay, typical example, you are logged in with your Windows computer into a domain, you open SharePoint with Internet Explorer, and you are automatically logged in. You don't have to do anything. Okay, this is using the Windows domain credentials. All right. Now, the last two topics that we will cover for this chapter, and then we will do another let's say 15 minutes break, is a new version of HTTP, which is called HTTP 2. Okay, so as I said before, HTTP 1.1 is the most common version of HTTP that we have nowadays. The new version that was published in 2015 is called HTTP2. Now, HTTP2 is an evolution compared to HTTP 1.1 that is focused only to improve performance. Okay, so we are going to improve the user experience. Why? Because HTTP, if you remember, was not created to be used with web applications. HTTP was used to transfer data for websites, for static pages. So we have abused this protocol, and we have pushed this protocol to its limits using different techniques in order to improve the performance of HTTP 1.1 until we reached a point where it was not possible anymore to improve the performance of this protocol. So HTTP2 was created. HTTP2 is based on some protocols that were created by Google. The protocol was called Speedy, actually. And before it was published in 2012, other companies joined into let's say, the effort of creating a new protocol, and then HTTP2 was published in 2015. Now, one of the main differences between HTTP2 and HTTP1 is that H2 is a binary protocol. It means if you open Wireshark and if you try to sniff the packets that are going through the wire, you won't see anything. Okay? Because with HTTP2, everything is a stream of data. Okay? In HTTP1, if you open Wireshark and you sniff the packets, you can see the HTTP request and the HTTP response. You can actually read it. Okay? So on the wire, these protocols are different. If you want to use Wireshark to sniff HTTP2 conversations, you have to add a plugin. Okay? Otherwise, you won't be able to see anything. Now, there are different things that have improved in order to increase the performance and reduce the latency in HTTP2, or H2, as it's called also on the standard. The first one is using a protocol that is called HPAC to compress headers. Okay, so we're not compressing the body, which is normally compressed when we are transferring data. We are compressing the headers. But this goes also a step beyond compression. There is, if you look at the specification of HPAC, there are basically like a database of headers that the client and the server can use, so that as soon as we say user agent is, I don't know, Firefox, that's it. That is not communicated anymore. Okay, we're going to set this user agent as Firefox as a variable with a number. That's it. That is what is going to be transferred between client and server. Okay, so that's, for example, how HPAC works. Actually, this is not in the scope of this course. So if you want to know more about HPAC, header compression, and so on, there are lots of articles on the internet that you can read. You can read the standard, actually, the RFC for HTTP2. We have true request pipelining. Now, what is request pipelining? Request pipelining is essentially having multiple requests sent at the same time inside a single TCP connection. Okay? Now, you have a TCP connection in place. You have 5 requests. You do 1, 2, 3, 4, 5. Okay? In the same TCP connection. The problem is that with HTTP1, this pipelining didn't work. Why? Because even if you do the request in the same TCP session, HTTP1 actually specifies that the responses must be sent to the user agent in order compared to the request. So if you have request number 1, 2, 3, 4, 5, and then response number 5 is ready, the web server cannot send it. If response number 3 is ready, web server cannot send it. until response number 1 is sent. Then response number 1, 2, 3, 4, 5 are sent, and then you have this kind of pipelining. HTTP1 suffers something that's called the head of line blocking. Okay, so basically, until the first request is processed, the other requests cannot be processed by the web server. So that's why HTTP2 is called true request pipelining. With HTTP2, you got 5 requests, and then you got 5 responses. It doesn't matter if they are in order, not in order. It doesn't care. Okay, the web server will start to send the responses as soon as they are available. Also, HTTP uses one TCP connection, just one. If you analyze the traffic between your web browser and the web server using HTTP2, you will only see one TCP connection. That's it. If you analyze the traffic between a normal web browser and a web server using HTTP1, you will see multiple TCP connections, up to 8 TCP connections. They are opened at the same time to the web server to fetch content from the web server. Why? Because of the line blocking issue. All right, we are basically bypassing the problem by saying opening multiple TCP sessions. So statistically, the other sessions will get the content while maybe one is blocked, so the content will be transferred later. The problem is that the more TCP sessions you open, the higher the load on the operating system of your client is going to be, and also of the web server. Okay, imagine 100 users opening 8 TCP sessions at the same time. It's 800 TCP sessions. That's a lot of work for that poor web browser or web server. All right. This is not done anymore with HTTP2. HTTP2, one TCP session. Now, depending on the browser that you use, if you use Firefox, for example, Firefox opens, I think, 6 TCP sessions by default with HTTP1. Internet Explorer, I think it's 8, like Chrome. You can actually check this on the internet. There are different information about these sessions. And finally, we have server push technologies, and this is fantastic. Okay, server push technology is something that will cut down the latency enormously. Why? Because the server, while you are requesting content for your web application, will start to deliver responses even if the request is not created. So let's say that you are downloading the index.html page. Okay, so you're saying get index.html. The server knows that if you are requesting that page, you also need a CSS file. You also need a couple of JavaScript files. You also might need a couple of images. So what the server will do, it will start to push the content as soon as you request, for example, the first page. This means that with one request, you're going to fetch, for example, 5 items, which is something that will really improve the performance of HTTP. Now, HTTP2 is at the moment used by, let's say, 9% of all web sites on the internet. So, but this number is increasing. So we will expect that by the end of this year, HTTP2 will actually take over. Okay. Yeah, I think it's 9%. If not take over 1.1, it will actually have a very high number of utilization. There is a question. Can you please elaborate on how HTML5 will help us against attacks like Chrome on the new version will be blocking all Flash and HTML5 and use HTML5? All right. So HTML5 is the new version of HTML. Okay, and this is specific to the programming language. Okay. I will not dive into the programming languages because it will take too much time to explain everything. All right. Let's say that Flash was a technology used to deliver content when static pages and dynamic pages were out there, and Flash were like small applications that were executed in the browser, and you could interact with these applications. That's why you have games with Flash, you have banners, you have a lot of things that were made of Flash. The problem is that this is like an application that is running on in your browser. And this application was not designed properly. All right, so it had a lot of problems in terms of security, in terms of performance, in terms of utilization of resources, and so on. So what is happening is that some companies have realized that it's not good to keep Flash in the web browsers on by default. Okay, companies like Apple have realized this years ago. Okay, when they have published the first version of the iPhone. Okay, they said no Flash in our mobile devices. Why? Because it was a security issue. Okay, performance issues and so on. Other companies like Chrome and also Firefox will publish new versions of their browser saying we don't provide support to Flash. We only support click to play. All the rest will be automatically switched to HTML5. HTML5 is the evolution of HTML, will allow you to have some content to be streamed or to interact with some content. Okay, so you have new tags, new way to formulate all your HTML statements, so it's more interactive, let's say, than HTML, let's say, 4. Okay, so that's why some companies like Google is starting to block Flash, okay, in Chrome. But again, this is one step above, right? This is above HTTP. Yes, the HTML was when it was created with a specification, and then they didn't add up the numbers, and they basically keep the specification. I don't even remember what is the latest one, but they just added new specifications. That's it. HTML5 is the new one. Actually, it's not more new because it's been published years ago. All right. Now, the last thing that we will see for this module, and then we will do, let's say, 10 minutes break, is the WebSocket protocol. Now, HTTP is not a two-way communication protocol. Okay, it means that with HTTP, you can have a request and then have a response, and this is called like an half-duplex communication. Okay, you cannot have a request and response at the same time. All right, this is pretty much like when you're using a radio. All right, you use a radio, you speak, and then you say over or something, and then you basically open the mic, and then the other guy will speak to you, and then you cannot speak at the same time. Okay, because he will not be able to hear you, and you will not be able to hear him. That's HTTP, request, response. WebSocket is a different protocol. With WebSocket, you can have full duplex communication, pretty much like what you have with your phone. With your phone, you can speak and hear at the same time. What is going to happen with WebSockets is that a web application might be designed to use WebSocket, so the browser will basically parse the code of the web application and will say, oh, look at that. I have to use WebSocket. So I have to move away from HTTP to WebSocket. So the browser will then create an HTTP request, okay, that will ask the web server to upgrade the connection from HTTP to WebSocket. If everything is fine with the web server will then say, all right, that's fine, 101. Okay, so status code 101, switching protocols. Okay, so from that moment on, we're going to talk with WebSockets. Then a TCP connection is open, and inside that TCP connection, bidirectional messages are exchanged. Okay, data is exchanged inside this WebSocket protocol. Now, don't be misguided by this slide which says HTTP handshake. There is no HTTP handshake. It's just that in order to open a WebSocket socket, you need to have an HTTP request and an HTTP response. Then you can use WebSockets. Okay. Now, you might be asking, so what's the point of having WebSockets if we have HTTP2? Well, that's a good point, actually. It is a good question, because HTTP2 actually gives you somehow a full duplex communication, all right? You can send responses and messages at the same time. It doesn't matter. So we will see. Some vendors, some companies are starting to use WebSockets because sometimes they are easier to implement. Others are starting to switch to HTTP2, okay? What I think is that we will for sure see that more and more HTTP2 is going to be used compared to WebSockets, but we will see. Okay, it's too premature to actually say anything about what is going to be used for full duplex communication. There is a question: can we use WebSockets with version 1 and 2? Yes, we can use WebSockets also with version 2 because it's something that it is the web application that wants to use WebSockets. And the problem is that it's meaningless. Okay, if you are using HTTP2, in my opinion, there is no point of switching to WebSockets. Yeah, that's right. HTTP2 has a single TCP connection, so why bothering, right? So this is something that we have to cover because the WAF actually supports both HTTP2 and WebSockets, as we will see today, actually. All right, so do you have any questions regarding this module? There is a question regarding the labs. You said that we will maybe do the labs. We will do the labs for sure. Okay, it's just when we're doing the labs that might change. Okay, we might do the labs after we finish web application and security, or we will do the labs at the end of this of today. Okay, just right at the end, I will give you the time to do the labs. All of you will have a lab environment. Okay, I made sure that we have 13 lab environments available for this course. Okay, we give you all the information regarding how to connect to environment before we start the first lab.